So first talk of the day is from Angie, and if you don't know who Angie is, well then, and you're involved in IT security, well then you should be sent back to the mailroom, as they say. So, security architect at Microsoft, which is the beginning of a very long set of qualifications. So without further ado, if you can come up to the stage and make us start in, and absolutely loving the talk titled Too Many Secrets. Who is old enough to get the reference? Too Many Secrets, C-Tech Astronomy, yes. Anyway, yay, good. There is a hug available for each and every one of you if you need it, okay? So without further ado, off we go.
Thanks, Garth. It is absolutely my favourite film, and there's none of it in the slide deck, sorry. So, welcome to Too Many Secrets. You can run, but you can't hide from Windows forensics. Wearing my private investigator outfit, just for you guys. Today's agenda is where it all begins with a forensic investigation, key investigation areas, anti-forensics, and then where do we go from here? Let me talk first a little bit about who I am. So I'm a security architect at Microsoft. I've got a master's in applied cybersecurity that I did at Queen's, and it absolutely broke me. I recently passed GCFE, which is a Windows forensics exam. And I mean, I've basically had a load of different jobs. I've been in and out of tech jobs for a long time, but I also was a teacher for a while. I made some VR things. I ran a bookstore. I had an artisan tea company. I worked for the Dyslexia Association, all sorts of stuff. And I'm really passionate as well about community things. Part of the reason why I'm here today. I'm also on the steering group for InfoSec and I and B-Sides Belfast. And I was really delighted to hear actually that one of the biggest meetup fest things was the NI Game Dev Network, because way back a long time ago I started it, so that's nice. I don't do it anymore. What I do not have a private investigator license. This is a joke. And I also don't have a job in forensics. My day job is architecting things. It's not forensics at all, and I don't want to give the wrong impression. I'm passionate about forensics. I'm really interested, and I'm kind of just on a journey of like, what can I do with this? How can I get more qualified? How can I move into this area? But I do not work in forensics at the minute. So let's get started. This is where it all begins. So forensics is all about recovering data from systems and investigating it to piece together what's happened. And so you can imagine that's documents, pictures and multimedia, financial files, internet browsing and email, and also file artifacts, which are like little pieces of files or temporary files or deleted files. And with Windows forensics, there's also lots of system events and settings that your computer records in order to improve your user experience. And that can also be used to work out what happened. So I do have an example. It's a little bit old. In 2017, in the course of investigating an entirely different crime, the police discovered a whole load of porn on MP Damien Green's work machine. And this was a massive news story at the time. And he denied it. And he shared a password with the staff in his office. So he said, it wasn't me, it was my staff, probably. And lots of other MPs, of course, they support each other, so they came out to support him. Nadine Dorries tweeted that her staff also log on to her computer on her desk with her login every day. And it's perfectly normal. And so it became such a big deal that the Information Commissioner's Office got involved. They wanted to investigate, and they wanted to remind everybody about their obligations under GDPR. And this other chap, Stephen Pollard, who's an editor, he came out to say he doesn't have any idea if Green watched porn or not on his work machine, but that the argument put forward by police that he's guilty just because he was logged on when it was downloaded is risible. But is that true? So I also saw someone at the time say, if a forensic examiner said that it happened, then it happened. But how do we know? Great question. So Windows forensics is not some monolith. There's lots of different types of investigations that require different sorts of forensics. So If you've detected intruders in your network, speed is going to be really important. You can probably start looking at credentials and logins. You probably don't really care too much about very strict preservation of evidence, because the goal is to understand what happened and to fix it really fast. For workplace crime, that's going to be like fraud, stealing company data, that kind of thing. HR or legal are more likely to be involved. So you do need to think about evidence preservation. You are looking at different logs, probably activity logs, logs tracking documents, or other data access. For criminal investigations, you have to strike a balance between the speed of the investigation and the evidence preservation. I mean, is it a kidnapping? Or is it a multi-year operation to make an extensive case against a drug lord? And you're going to have to think much more about things like chain of custody, about the evidence preservation, having really detailed and unbiased documentation, because you need the audit trail of that so that the other side in court can reproduce your results. And so you'll be focused on things like the timeline of events, the contacts that the people had, just focus on different logs. And for private investigation, that's more likely to be domestic cases or accident reconstruction, that kind of thing, where the results might not end up in court, but there's important decisions being made about people's lives because of the results. So you need to focus on a lot of corroboration, the timeline of the events, but not necessarily speed, not necessarily really very strict court-based evidence handling. So, regardless of what you're doing, the first steps are kind of basically the same. And it is tricksy if there's regulatory involvement. I don't do this stuff. Certainly law enforcement forensics looks very stressful to me. Anyway, so the first step is triage. You have to prioritize what you need to collect first, based not just on the type of investigation, like we said, but also the state that you find the machine in, because you have some things to consider. If it's powered up and it's logged in, you can grab a whole bunch of detail from memory, sometimes login credentials for things, sometimes chat conversations. But more importantly these days, if there's encryption present, you don't want to power off the machine, because then you won't be able to access it again. So there's other volatile data you could also grab, things like current active network connections, which will disappear if you turn it off, running apps, any listening ports, and also that would be the time to collect data from cloud services while they're still connected, if you're legally authorized to. The second part then is the image capture. So first of all, we try to work out what logs we need that will give the greatest return on investment. You can imagine if you sit down with your machine and went through everything on the hard drive, it would take you centuries. There's no time for that. We've got to prioritize. So often there's only a partial image taken at the scene so that things can get started more quickly. And there's a couple of types of images. You can take the physical image, which is an exact copy of the bits on the drive, but it takes a bit longer, costs more to store, costs more to manipulate. And if there's encryption, then it's no use. But it's also the most forensically sound option. So the logical image type is the currently accessible objects in the file system. So it's going to miss some operating system internals. It's going to miss some fragments and deleted files in unallocated space. But maybe it's better to get going a bit faster. And then we're going to look at processing. So ideally, this is the part I would be liking to start at. I don't want to do all that stressful collection and triage stuff. I just want someone to hand me the nice image already ready to go. First of all, we're going to back it up, because if our tools or ourselves accidentally make changes, that's a problem. So let's make a backup. And then we're going to run our tools against the image. So things like raw logs are often in quite unreadable formats, because they're not for humans. And so you can do manual work on them, but it's very slow and very painful. So you set your tools to work parsing the logs into a nice format that's more understandable. So what kind of things can we potentially find? So there's way too much to cover, so I've just highlighted a couple of examples on each slide. So the first one, the MFT, is the master file table. And it's a database of info about every single file on the system. It keeps a log of all the files that have changed on the system, what caused the change. You've got things like size and timestamps and permissions, and then also a link out to the rest of the contents of the file on the hard drive. Now, timestamps mean that we can use this to build a timeline of events. And deleted files in the MFT, I've skipped ahead, deleted files in the MFT just get a little flag changed on them. So now the computer knows it can use the space for something else, but the file contents are still in that spot on the hard drive. So if it hasn't been overwritten, you can still grab it, or parts of it, and each file has a header, which explains what type of file it is, so that the file carving tools look at that and scoop it out and recover the file. The registry is just a big database of settings. I like to think of it like a big sprawling city. There's lots of different buildings, they've got lots of different uses, not all of them are useful. So again, we're not going to look at everything, we're going to prioritize what we're looking at. So the main things that we're going to look at in the registry are the SAM Hive, which is user info, IDs, things about account creations, last logins, last field logins, and cloud accounts. The System Hive is operating system settings and services. Security is all about like user authentication, user behavior, file and resource access, a little bit of is there any modification of settings going on, and then software, application settings, product keys, all that kind of stuff. So, logs. Out of the box, Windows 11 has over 100 different types of logs by default. And they're not for surveillance, really. It's just things that the machine does to function. And settings that the operating system or the apps need to remember in order to keep working, that we can also use for investigations. So when your PC starts up, your last user to successfully log in pops up on the screen. How does it know who the last user is? How does it know which desktop wallpaper to load for you and which Dropbox account to connect? I mean, it's all logged, and it knows who the last one to log in was because it stores all the date time information with those details. It also records field logins and whether they were remote or at the keyboard, whether they used a Windows account, all that kind of thing. And logs can be text or database. They're in very, very variable formats across the system. Like, you can expect to see JSON, CEF, but also like Windows event logs and protobuf and all sorts of weird stuff. They also have extremely variable timestamps. They're not always 100% reliable, and it very much depends on which log you're looking at. So you need to either know your stuff or you need to be happy to go on Google just to make sure. They store details about when things were created, when they were accessed, when they were modified. And part of the issue with them is also that they're not even all in the same time zone. Some of them are UTC, some of them are system time. So if you are in another country and you have a UTC offset, it's going to be in whatever time that is. Some are epoch time, some are WebKit time, which I didn't even know existed until a couple of months ago. It's very stressful to deal with timestamps, and I know that's the case for everybody, not just forensics. Okay, so now we know kind of what we're using to look. Let's talk about file usage. So I'm going to go just through some basic examples. Things like the OpenSave MRU. Now, MRU is most recently used, and it's a list of files. And this one tracks files that have been opened or saved via a dialog box. And that is in order to suggest to you, when you go to save your file again, oh, maybe you'd like to save it in this location you saved last time. It's got to work out where that is by remembering, so there's a log for it. And the same for opening files. Similarly, recent files and Office recent files MRUs track your recent files opened in order to populate those recent file lists that you see whenever you open an application. So, When you use your computer, you can open programs, you can drag their window positions around, you can maximize them and change the size. And if you close them or you shut down your machine, when you open them again, they'll pop back up in the same place. How does it remember that, though? Obviously, it logs it. And one of those logs is called shell bags, which is a hilarious name, but there you go. So shell bags is folders accessed on local, network, and removable drives. So it's quite a lot of information, and it's per user. And it has timestamps for the first and last interaction, and it also persists, like the log persists, even after you've deleted the folder that it came from. Shimcache is also a log which helps with backwards compatibility with older Windows systems. But it can tell us information about whether you opened a folder and viewed the contents, or whether you launched any files. So if you compare the Shimcache date times with the shellbag ones, that shows what windows were open at the time and what position on the screen they were in. So if we think back to our lovely MP, we can tell when the porn was on the screen, and we can tell if other things were on the screen at the same time. So maybe those things were on the screen at a close enough interval that it would mean it was very unlikely that the user in the seat changed in those times. Thumbs and Thumbcache also store thumbnails of pictures, documents, and folders. That's the thing that gives you your little view every time you go into a folder. So you can correlate these with Windows search logs for file names of those things, paths, and other metadata about them. And that is a log that also persists even when the original image has been deleted. And then we also have cloud storage. So OneDrive, Dropbox, all those things. Even though it's cloud storage, there is some metadata that exists locally and is stored locally, usually like timestamps and file names. Even if you're not choosing to sync with your machine and you're not storing local copies, it's still storing some metadata. So maybe you're thinking to yourself at this point, listen, I'm just going to keep it on a USB. But that would also be a mistake, because USB Store has a list of every USB that's ever connected to your machine. And when you plug in a USB stick, the computer records the make and the serial number and the date time and some other stuff. So, you know, when your friend Bob is saying, "No, mate, I never saw that in my life," you can tell if it's been in his computer or not. So how does this help us? Well, it helps us to prove the user interacted with files and folders. It gives us a timeline of the user interaction with those files and folders. It helps us to identify network and removable storage locations, and also just to identify trends in their behavior. Let's talk about applications. So, link files allow you to pin things to the taskbar or create shortcuts, because they're one little file, but they point to the place in the hard drive where the application is going to come from. But there's a log of those, again, with date time information about when it was created, when it was last accessed, all stored. So maybe you delete the program, or maybe you even delete the taskbar item. But did you remember to delete the link file? And there's other records specific to the taskbar that include whether the app is in focus or not. So you can really tell what date and time someone has been looking at something and whether they were actively focused on that thing. This is an interesting one for me, Capability Access Manager. For all of those times you're on a Zoom call or something and it pops up, do you want to allow access to your microphone? Or those terrible websites that say, give us access to your location, and you have to keep clicking no. That is stored somewhere so that next time you go back to the site, you don't have to keep doing it. And so we then can tell per app whether they've got microphone permissions, whether they've got webcam permissions, whether they've got location permissions, but also the start and stop time. Strum logs, this is monitors system resource usage. So this is just to do with the health of your machine mainly, but it keeps it for between 30 and 60 days for every single app. It registers which user used the app, what network was available at the time, and the bytes sent or received by the app. So you're going to struggle if you want to say, oh, the app is on my system, but I didn't use it. We also have background activity monitor. So again, this is system health, it's power management. It stores the full path of the app and the last execution. And prefetch, also to do with applications, it speeds up your system and makes it less annoying to use because it goes and it gets all the files and directories used by that app before you launch it. So the very first time you launch it, it goes and does all that, and then it has a list of them. So it knows what to go and get next time. And of course, it stores that somewhere. So we've got all that. And it also stores the first time you executed the app, the last 8 executions, and the total count of all the times you've ever executed it. And those are just like a few examples. There's loads more. Now, sometimes log data can be altered or deleted. So that's why we always come back to, we've got to corroborate everything. And you can see that there's multiple places where this stuff is stored. But that's really important for our forensics because we need to be able to not just rely on one single source. You have to find multiple things in order to push things past a reasonable doubt. So this helps us to prove user interaction with applications, timeline the user interaction, and again, identify trends in application usage. So browser activity. We all know about cookies and cache and bookmarks. All the major browsers store data in the user profile just to make browsing work better. So I'm ignoring cache and cookies. I'm going to talk about session restore. That's that thing where you accidentally close your browser and then when you reopen it, it pops up with all of the right stuff again. That's logged somewhere. That's how they do it. And the log has all your past websites from that session, all of the back chain of referring sites, and the session times. You're probably also storing autocomplete data. So that's autocomplete for websites, autocomplete for search terms, autocomplete for usernames, probably form data. If you ever see that, don't ask again for this website, and you think you're being clever by clicking no so that it doesn't remember your username and password. It's not remembering your password, but it's making a log of your username and the website so that it doesn't ask you again next time. So it still knows you visited. Browsers now, all the major browsers also have their own download managers as well as just the system download manager. So you've got a couple of things to think of there if you want to work around that. And this interesting thing called alternate data streams. Now, this is not just about browsers, but it's particularly pertinent to browsers. This is a pointer in the MFT, which has a little bit of additional info, and usually it's zone IDs. And so zone IDs are used in all the major browsers. They're used in email and Slack and Teams and things. And basically it says where the file came from. And that's whenever you download a file from the internet and then you open it up in Word and Word goes, oh, are you sure you want to enable editing? You know, this might be from an untrusted source. Because it's seen the zone ID, seen that it's from the internet, and it's giving you a warning. So, yeah. It's supported in all of the forensics tools. So it's pretty easy to use a forensics tool to just say, give me all the files that were downloaded to this system on Wednesday morning. Media history is an interesting one. So not just that it remembers your audio and your video file last play times. It remembers the watch duration and the last video position, which I find, I can see how as a user it's useful, but it's all logged. And then this, for me, is the slightly egregious one, Chrome Network Action Predictor. So it records letter by letter what you type into Chrome. And the reason is because it's trying to work out auto suggestions for you about what you might mean. And then it's also trying to predict, was it correct this time or did it get it wrong? So that it gets it better next time. And in order to do that, it's keeping a log of all of the letters individually that you type into Chrome. And I'm saying Chrome, but it's Chromium, any of the Chromium browsers. But it also means that sometimes it goes and prefetches things for those sites because it's predicting you'll want it, and then you don't use it. So that does mean that sometimes it has prefetched stuff that you didn't actually look at. So how is this helping us? This is proving that users never interacted with websites or media. It's identifying frequently used words and personal information. And it's also helping to identify the source of files. So there are some ways to get around some of this stuff, I guess. This is a Sherlock Holmes, the whole thing is a Sherlock Holmes quote, crime is common, logic is rare. So some of the techniques that we might use for anti-forensics is wiping. So when you expect that alerts or other data is kind of conspicuously missing, probably some wiping has happened. There was no incident with the dog in the nighttime. It was curious because they expected the dog would bark at strangers and nothing happened. And so that clued them in that there was something else going on. So we already know from MFT and the unallocated space that regular deletion is not really going to be enough. But you can use secure wipers. Timestamps, we know, not fully trustworthy all the time, but we can also use anti-forensics and modify them. So one of the signs that a file has been copied, for example, is when the modified timestamp on it is, let me get this the right way around, before the creation timestamp. That shows it's been copied from another place. You can really mess up this kind of thing can really mess up your investigation, because if I say I want to investigate everything between Wednesday and Thursday, but someone's changed the system time, that's going to mean that key evidence is outside of the scope that I have set. Or maybe that just casts enough doubt on the integrity of the data that I've got that it's no longer acceptable in court. You can also add a lot of confusion by doing things across multiple accounts. You can make it harder to join up events because they're distributed. You can go in and change file headers and extensions. Or simple things like just using private browsing. Well, I'll talk about that in a minute. So there are some mitigations for this, right? Like, for example, sdelete, which is a secure deletion tool. It does rename the files in order to write over the top of the file names, but it tends to do it like as just a string of zeros or something. So it can be very obvious that sdelete has been used. Does still mean the stuff is missing, but you can see then that there's been intent to hide something. So you can also go back and use backups or volume shadow copies to find out the state of the system before some of these things were deleted. So volume shadow copies are a differential, but you can actually use the forensics tools to replay them and view the disk contents as if it was the old version. And it'll even highlight changes between the new version and the old version for you. You just need to take extra care with the timestamp anomalies and the timestamp logic. You should check file headers in the tool. So quite a lot of the forensics tools, they'll give you the information, but they'll also give you the hex at the bottom. You can just cast your eye over that, make sure it reads as if you're expecting it to. Any suspicious file sizes, things that are unnaturally large files, have a look at those. In terms of user accounts, I think documenting your in and out of scope things really helps, because if there's a system with 6 user accounts and I know I'm only investigating Joe Blogs, but it turns out later that Joe Blogs has done other stuff, it's useful for me to be able to go back and say, oh, okay, well, there were 5 other accounts here, now I'm going to diversify and do something else. And private browsing. So private browsing does actually leave some traces. It's much, much reduced compared to regular browsing, but it does leave some stuff and it changes a little. So it's important to stay up to date, And actually, it's probably impossible to stay completely up to date, so it's important to have a mindset where you're happy to go and do research. And for everything that we're doing, we want to corroborate with multiple logs in multiple different places. So let's talk about where we want to go next. So first of all, tools. Big software suites automate and process almost everything, but they're very expensive. So that's Encase, Magnet, they're quite expensive. But maybe your company has them. Excellent to get some hands on. There's a load of free, there's so many tools you couldn't even. There's a load of free tools. Cape is excellent because it does the collection and the processing of a bunch of stuff. And once you establish a workflow, you can kind of just set that up for automatic things. Eric Zimmerman's tools are also excellent. A lot of the SANS material is based on his tools. He has written them and open sourced them. And actually, the Microsoft Incident Response team has proprietary tooling based on those open source things. You can also do, he has all sorts of things that will automatically create timelines, automatically pick out things in the MFT that are weird, all that kind of stuff. And you can write your own. So the interesting thing about the tooling is that there's always something changing and there's always something niche happening. Whenever they started to, let me think, HoloLens or something, right? That's definitely leaving traces in your system. But there's not necessarily, there probably is now, but there's not necessarily a great deal of tooling that's handling that. If you find something niche and you don't find a tool to do it, go and write one. It's a brilliant way to make an impact and everybody will thank you for it. Jobs, highly recommend Forensic Focus. There's fraud jobs, e-discovery jobs, incident response jobs. There's also law enforcement, but it's quite hard to get into because they tend to take law enforcement people and give them forensics training rather than taking forensics people and giving them law enforcement. Security clearance probably helps a little. You can go learn a bunch of stuff. So I recommend dfir.training. There's a whole bunch of free stuff there. Queen's and the Open University have forensics courses. SANS have a very expensive forensics courses, but they also have a free summit every year. And of course you can do CTFs, which help you practice. And I'm a big fan of, if I want to get into an area, you need to sort of try to absorb the lingo. So go and follow some people on social media. I definitely recommend Brett and a couple of people on, I tried to take the Twitter people that were in the UK and Ireland. So Forensicator and Taz are great. And then also just the mindset, right? The difference between just collecting the data and analysing the data and actually going off and investigating other leads. And then just staying curious. And the idea that winning is not catching the bad guy. Winning is uncovering the puzzle, even if the puzzle exonerates the bad guy. The winning part is doing the work. So thank you very much for listening. You've been lovely. I would like maybe to do a workshop or something next year. So if you think that you would be interested in that kind of thing, let me know. And that's it. Thank you very much.
Thank you so much for a fascinating talk. This is my bad. We knew this one might run a little bit long. So Angie has kindly said that she will take questions in breaks, over lunch, at any time of the rest of the day. But please just go find her.